All right, so I'm live here today, keeping things on track with Swift and 52 weeks of Swift, and I'm going to dive into the collections today, which are very useful if you want to do things like build, for example, lists and dictionaries and sets, and typical things you do with languages. I I roughly know them a little bit, but I want to probably brush up a bit, and that's why I'm going to cover this. In fact, I'm actually covering the whole language guide step to step, and we'll start with sharing my screen here, and let's go ahead and do that. So let's do that. We'll go ahead and share my screen, and we'll get into. I'm going to do entire screen, and I'm going to share a picture here of a Swift documentation around collection types. So I'm just going to go through this documentation. I'm still a little bit hampered with a finger that's recovering from surgery, so I'll be a little bit slow in typing things, but I can always grab things if I need to. So I guess to start off with, if you look at Swift here, there are three primary collection types known as arrays, sets, and dictionaries. So this is, essentially identical to the Python language. And so this may be one of the things that they're doing is just copying that. And from the documentation here, you can see that an array has an index and it starts at 0, and then the values are inside of that array. So very similar to a Python list or an array in, Bash or something like that. The set here allows us to uniquely have items inside and do operations around sets. A dictionary is a key value based interface. And so, really to get started with, we also need to talk about mutability. And so with a array, set, or dictionary, you can assign it to a variable, and then it's either going to be mutable or immutable. So in the case of if you assign an array, a set, or dictionary to a constant, that collection is immutable, and the size and content can't be changed. So basically, it's a good idea to create immutable collections in all cases where the collections don't change, because it's easier to reason about the code, and also the compiler can optimize performance. So this is one thing that's nice about a compiled language like this, is that by using things that are immutable, you actually get better performance. And also your code is going to be a lot safer as well. Arrays store things like an ordered list. There's different shortcuts for things. So let's go ahead and just dive right into the code here and say creating an empty array. This is a good one to start off with. So I want to go through here and I want to paste this in. We can see that var sum ints. I can actually say I'm going to create this empty array, and then inside of it, I'll go through here and do a print statement underneath. So let's go ahead and do that. And here we go. We have sum ints is a type of int with 0 items. Perfect. Now, if I want to go ahead and append things to it, what I would do is I would use the appends, which really does look essentially identical to Python, right? Where you use a dot append and you just put something in. And now if I go through here and I look at the values inside here, if I just type in, for example, sum ints dot count, it should show me what's inside. I think I don't even need to call it. I can just look at the attribute here, and we can see that sum ints dot count, there's one thing inside of it, right? Because I put the 3 inside. Now, if I go through here and I make an empty array, right? If I be this example right here, so it's a var 3 doubles, and then what's going to happen here is that it's going to make 3 of these by default inside of this array, which is kind of neat, because then basically it's got things all set up for me in the format that I want and the type that I want. You can also create an array by adding 2 arrays together. And so what we'll do here is I'll first create an array called another 3 doubles, right? So this is what I did before. So it's got those default values inside, repeating 2.5. And then if I want to essentially make another one here, var 6 doubles is equal to 3 doubles plus another 3 doubles. And basically what this does is I need to get the one from earlier that I had got rid of. So I'm going to put that back at the top. There we go, var 3 doubles. And then I'm going to say var equals 6 doubles equal 3 doubles plus another 3 doubles. Go ahead and put this in. Here we go. And then what it's going to do is it's going to basically combine those two arrays because they're of the same type. And I can essentially just merge those two things together. So that is pretty neat. Again, you can do a similar thing in Python, merging lists together. You can create an array with an array literal as well. And so this is basically a way to basically have a shorthand way to create an array. So if we go through here and I put in var shopping list and I say string, so it's going to have strings inside, I can initialize it with two values. And so var shopping list colon string. So of type string, I want eggs and milk in here. Great. And then if I go ahead and I type in, for example, shopping list.count, then this will give me the fact that this has got two items inside of it. And if we go down here, thanks to Swift's type inference, though, you don't have to write the type of array if you're initializing it with an array literal containing values of the same type. So that is pretty neat. In terms of type inference, I think this is something that's really lacking in a lot of scripting languages, is type in, like a clever type inference. They have dynamic typing, but they don't, or duck typing, but they don't have this concept of, type inference. And it really is helpful because essentially you don't have to type in the types and it can save you a lot of time. So in this case of a shopping list, because I have the two things that are the same in there, I don't have to declare anything. So if I would, I don't know, make another variable here and I say more shopping, and I put inside of here, for example, just integers, and I put 1, 4, and 10, notice that this one would work as well. And so basically by really using that type inference to help me out, it is pretty neat. And if we look at, for example, the description, I can also, if I look at more shopping, I could pull all these different attributes out of the object as well. In this case, essentially how many things are inside. So what about accessing and modifying an array? Well, one of the things you can do is you can access it by slicing it essentially, or using subscript syntax. So in that latest example that I was using with, if I go through here and I say the shopping list contains items, that I'm going to use that built-in count attribute. But I could also do something a little bit more sophisticated and say if shopping list is empty, do some other operation with it. And so that's a nice way to handle how to do something. You also can do the dot append, which I used earlier, and the dot append will essentially add something inside of this list for us automatically. And so if I go ahead and I look at print, for example, shopping list, it will show me that I've got eggs, milk, and flour. Now you also can append by using the plus equal here as well, which is pretty interesting because it is actually a lot smoother in a sense because it's just less code than an append. It's maybe a little bit less clear, but if I go through here and I print this down below and I say print shopping list, you can see that in fact it's got the baking powder added to it. So that is one kind of neat thing that you can do in Swift, is that you can basically add items to an array by just using plus equal. And that's and you can actually plus equal actually a lot of things, which I think is a neat little trick here. I could definitely see myself using this if I was going to go through and build a few things to a list, and I want to, essentially append to it. It's not bad. Now, to retrieve a value, you could just create a new variable and go through and basically say whatever the name of the list is, and then add index that you're trying to get the value out. In this case, I say first item would be at index 0, which is correct because it's indexed by 0. And if I print this out, you can see that I've been able to get the eggs out. I can also mutate by using the subscript syntax. And so if I go through and I say, mutate the array, I would go through here and I say shopping list 0, 6 eggs. There we go. And I'm able to actually mutate that value where the 6th value before, I think, was cheese, because what's 1, 2, 3, 4, 5. Yeah, and then 6 was cheese. So I swapped out cheese with eggs, or 6 eggs. And so you also can do a range of values, which is pretty cool. So if I go to shopping list here, and I want to mutate everything from 4 to 6. So if I look at, if I just print this out here, we can even see what's inside the shopping list. Shopping list. And what is inside of here, we've got 6 eggs, milk, flour, baking powder, chocolate spread, cheese, and butter. And so if I want to mutate basically items 4 through 6, let's go ahead and do that. So I'll go ahead and say shopping list 4, 6, bananas and apples. And so what this will do, if I print it again, let's go ahead and take a look. So if I go through here and I just run these 2 lines, we should see that it's got 1, 2, 3, 4, 5, 6 things inside of it. And so even if there's a different length, it'll still be able to insert it inside of it, which is, I guess, what it would be doing then would be dropping, I think, that other value. So I think it's dropping the butter value, the 7th item, because there wasn't enough of a length of it. Now you can also insert something at a specific index. So you can basically put something at the top, which is pretty neat as well. So if I wanted to go through here, I wanted to say, like, put at beginning, this would go through here and give me the shopping list value, which is, again, pretty cool that it's able to give me that value. What else can we do here? So what if we want to use immutable variables? So it says, similarly, if you remove an item from an array with a remove, that method removes items at a specified index, although you can ignore it if you don't need to. So in this case, I'm going to do maple syrup, and I'm going to remove it. And I've got a new immutable variable called maple syrup. And I could also, basically build more things by, I don't know, removing last or whatever it is that I want to do by using remove last. So there's some neat little tricks here that are available on arrays that are, I think, quite handy, actually. Okay, what about iteration over an array? Let's kind of pop this thing up a little bit and go into iteration. So you would do the classic looping here, basically a for loop. And what I'm going to do is I'm going to say for item in shopping list. And let's go through here and put a print, right? So intuitive, how do you do a for loop? And this just prints everything inside of that shopping list. In fact, I could probably scroll this up a little bit. Look, here we see 6 eggs, milk, flour, baking powder, bananas. if you need the integer index, which is common, I do like that sometimes if I'm looking through like maybe like query AWS and I want to get, the key values and I want to count each of the results or something like that, or I'm querying a SQL database and I convert it to JSON and then I want to, print out how many values came out. This is pretty common for me. So how do you do this? You just add in for index value. So you put that into a tuple and you say enumerated, and then basically this will pop out and it will tell you the enumerated values, right? And so in this case, it just says item one. You make a print statement, do string substitution, and then put that out. So that's a fairly common thing that you see in a lot of languages, actually. Okay, sets. A set just stores a distinct value. So basically, this is a way of deduplicating things, is by using a set and a hash value for a set. A type must be hashable in order to be stored in a set. So there must be basically a way to compute a hash for a value. So an integer, it would be a good example of that. So let's go into here and let's create and initialize an empty set. So first thing I'm going to do is I'm going to create a mutable set here, var letters set, and it will be a character. And we say the letter is of type characters, right? And I can just go ahead and print this out. And this should show us this. So it says the letter is of type characters with 0 items inside. And so if I want to insert a letter, then I could go through here and I could say letters.insert. And the next thing I could do is I could also make it an empty letter again, right? But it still keeps the set character associated with it. And let's see, create a set with an array literal. So you can also initialize a set with an array literal as a shorthand to write one or more values as a set collection. So in this case, what I would do is I would say var favorite genres, make that a set string, and then these would actually all be strings inside of here. So this is basically a set with a bunch of string values inside. Makes pretty intuitive sense to me. And then if I want to go through here and I want to create another flavor of this, it says a set can't be inferred from an array literal alone. So set must be explicitly declared. But in the case of like all string values like this, it can actually figure out that I don't have to declare the type for these values because it can infer it. To access and modify, you can first figure out a count just like a list, right? So if I go through here and I do that, I can put a list here. But if I say if favorite genes dot count, or if favorite genes is empty, print out some other thing here. So here we go. I print this out. So basically, I can do a similar thing that I would do with a list. Basically, check first if it's empty. If not, do some operation. And in this case, I could do insert the word jazz. And then if I want to scroll down, I can also remove things like remove different genres inside my strings or whatever inside the set. And then if I want to check whether a set contains a particular item, you can just basically say if favorite genres contain funk. There we go. We can go through here and we can print it out. It's too funky in here. And then if I want to iterate over a set, you can iterate over values in a set with a for loop. So very identical almost to just a regular list. You would just go through and do a for loop for it. You can also do sorting, which is pretty neat. So Swift's set type doesn't have defined ordering. So if you do care about ordering, you can use the sorted method, which is pretty cool actually. That I can just build in a little sort here by default, and it gives me that value. So what about things you would do with sets? Some of this stuff is pretty cool, especially for data science type operations. is to look at intersections, symmetric differences, union, subtraction. This is all, set theory here. So if I wanted to paste a bunch of this stuff inside, of my browser here, let's go ahead and do this. I paste all this in. I can take a look at things like, odd digits, even digits, single digit prime numbers, make unions, intersections, sorting. So all kinds of cool mathematical stuff by doing sets. And you can, basically go through here and even use, in this case, I have Unicode characters, which is pretty cool that you can do that visually, because it does actually lend to making it more clear about what it is that you're doing, right? Because then I could basically say, is this animal a subset of this other animal? Is this a superset of this one? Is it a disjoint? So those are pretty cool features of the language, actually. All right, so sets are done. The last thing I'm going to cover is a dictionary, which is really the bread and butter for me for a lot of languages that I use. They call it different things in different languages, but basically key value pair. So create an empty dictionary. You can also explicitly declare the type, right? So I can say var name of integers, make it an int string dictionary, right? So the key would be an integer, the value would be a string. And then inside of here, I could just assign a value, right? So I'll go through here, names of integer 16. I put in the integer 16, the string called SIX TEEN, right? 16. And then if I wanted to just kind of wipe it out here, you can see here I wipe it out, and because it's a mutable variable, I can do anything I want. I can also create a dictionary within a dictionary literal, which is really common if you're converting from, for example, JSON, right? Like you have nested dictionaries. So if I have a dictionary that's got a string key, string value, and these are just basically airport codes, I'll go ahead and put these in. And then inside of here, what I could do is I could basically put, make another one called, let's see here, I got airports. So you can also assign with a dictionary, you don't have to declare the type, which is pretty nice that it can do type inference here. Although in this case, you don't have to write the type of the dictionary if you're initializing with the dictionary literal. The initialization of airports could be written in a shorter form. So that does look to appear nice if it works, although I'm not getting that same result here. Let's go ahead and try invalid read declare. Okay, here we go. I think I'm back here. Yeah, you can't redeclare the same thing. But what I can do is I can access and modify a dictionary as well by doing subscripting. So essentially you would just go whatever the name of the key is and then assign it a value, and then you got a new value inside. And so if I go and I just print out airports here, you should see that LHR is now added. Airports, right? We've got LHR London, YYZ, Toronto Pearson, DUB Dublin. And then if I want to see a airports dot count, it should tell me how many records, and there's 3 records inside. So at least for me, pretty intuitive, the dictionary syntax in Swift. And then you can also do things like update values, for example. So the update value returns an optional value of the dictionary's value type. So basically this optional value contains the old value for that key if one existed before the update, which is kind of an interesting concept. So you can get the old value and keep it around. You can also do things like, if else statements with dictionaries, and you can also assign it a nil. So for example, if I wanted to basically assign this APL to nil, I could then go through and print it out, and I could see that in fact one of one of these actually doesn't show up anymore because airports LHR, yeah, it doesn't populate. You can use a substruct to remove a key value pair from a dictionary by assigning a value of nil. So basically, that just removes it from the dictionary. Where if it was there earlier, we could actually do this. We could print this, make it available, and then print it out. And then you will see that it's actually there. Right? We see that Apple's there, but then if I want to nuke it, and I say, nope, delete the key, then this next section where it says airports nil, it will actually remove it. You can also remove a key value pair from a dictionary with the remove value for key method. So airports.remove value for key and then put in the key, which is a little clumsy if you can just do the nil. Also, to iterate over, you can pull the key value out of a tuple, so that is pretty nice. This is again is very similar to other languages that I've dealt with. It just lets you do key value pair printouts. You can also just get the keys. So I use this a lot with querying APIs. Hey, give me all the keys from this JSON data structure. There we go. We can just look at only the keys. You can also look at only the values. In this case, I would say for airport name and airports dot values, right? Just show me what the values are. And that's pretty neat. And then you can also use a dictionary's keys or values with an API that takes an array instance and initialize a new array with the keys or values properties, which I guess is kind of neat. So you basically are just kind of pulling out a section of that. So I guess I'll run that. That'll be the last thing I take a look at. Here we go. And so we go through here, and I just type in now airports. I've been assigning these into an array, and then if I want to go and I want to grab the strings out of the values, I can actually assign that to a string, and then I can go airports, and then I've got a bunch of strings inside of here, and I can actually print this out like this. So pretty straightforward actually for the collections using Swift in a nutshell. Not bad at all. And next week I'm going to cover control flow, and then the week after that I'll cover function. So I got a lot of stuff to cover in the language reference. Definitely making some good progress here. And maybe just to summarize is, hopefully this is useful to other people other than just me. I'm going through and brushing up on the Swift language, and I will be here every Tuesday at 3 p.m. Eastern time. All right. Talk to you soon.